Here's the region. So there's the region. And we're rotating that about the y-axis, so that's going to look like this. So can you imagine, just off the bat, what we're going to get when we do that? You need to be able to imagine that. What's that? Solid. Yep. Yep. Okay. Why is everyone standing up? Okay, so we're going to get this shape right here. So how do we generate that? Well, we go back to our region, and I said use a typical strip parallel to the x-axis. What does that look like? Oh, shoot. Oh, no, that's 3/4. There we go. So here's our typical strips. Will be parallel to the x-axis like this. So what will we get when we revolve just the typical strip? That will be our little element that we're going to add up to get the volume. So what do we get when we revolve just the typical strip? Pancake, but this time it's a horizontal pancake. Okay, so we're going to have all these typical pancakes. What we get when we revolve that blue strip around, and that's going to be that red typical pancake. So we want the volume of that. So the volume of that will be pi r squared h, because it's a cylinder. It's basically just a squashed cylinder. It's a squashed cylinder. So what is our height? What is our height? The little small dimension? This is a change in y, right? Change in y. So that is delta y. And what is our radius? So our radius is, it's basically the length of the strip. That's the radius right there, from here. So how do we symbolize that dimension right there, the radius? You don't have to do minus, right? Because it's coming from the y-axis. That's just simply x-coordinate, right? The x-coordinate is how far horizontally you are from the y-axis. So that radius is just simply x. It's just simply x. You don't need to do minus because it's not. You don't have a change out away from the axes. You truly have the x-coordinate. So down here we got pi. The radius is simply x. X squared delta y. So because we're doing in terms of y, we need to get x in terms of y. So we need the x-coordinate of this in terms of y. So we got to come up, that's the x-coordinate of the curve, right? The x-coordinate of the curve is going to be the x-coordinate of this. So we're going to solve this for x. It's going to be y minus 1 equals 1/2 x to the 4th. 2y minus 1 equals x to the 4th. So our x-coordinate is the 4th root of 2 times y minus 1. The radius of our pancake is the length of the strip. The length of the strip is the x-coordinate on that curve. In terms of y is what you get when you solve y equals 1/2 x to the 4th plus 1 for x. So it's going to be pi times x is 2, y minus 1, all to the 1/4. And that all to the all squared. That's the radius squared, delta y. So there's our setup work. So now we're ready to what? Add up all of those. We're going to add up all the volumes of those typical pancakes, starting from where? Where's the first one? The first one is down here. And that's at y equals 1. And then the last one's at y equals 4. So from 1 to 4 of okay, ask. I'm sure there's other people with the same question as you. So did I lose you? Does it make sense? Ask if you're not sure. Please. Always show your work. So if you're ever unsure about showing your work or not, show your work. Yeah, I guess in this case it's possible that, because you had it ahead of time. But always show your work. I'll just think from here on out, if you're ever not sure, just always show your work. Okay. Questions about the mathematics? Okay, so let's go back to our back to this one. Okay, but now we're gonna do a different rotation on this one. So this was our y equals x squared. I am, thank you. This is our y equals x squared, y equals 8, x equals x-axis. But now I'm gonna revolve around y equals 70. What is the coordinates of this point right here? What are the coordinates of that corner point of this region? What are the coordinates of that? 8 and 64. So we're gonna throw a horizontal line up there above that at y equals 70. Okay, and then I'm going to revolve that region now about y equals 70. I did not design a nice animation for this, so can you imagine it? So I'm going to draw it, but can you imagine what you'll get for a solid when you take that purple region and rotate it about the line y equals 70? So what about this point 864? Where will that end up at 180 degrees? Right about there, right? And then this whole edge here will end up like this.
So this one will actually be
Well, a very weird one. They'll have a hole in it. It's going to have, yes. You're saying you're going to stick your hand through the middle of it. You're going to have a hole in this, okay? So that edge will rotate like that, and then we'll have this edge on the x-axis will rotate around like this. So that's what that region will look like at 180 degrees of the rotation, but you got to imagine it all going all the way around. So let's see if I can draw it. Something like that. Okay, can you imagine that? Can you imagine that? So it's like it's kind of like a cylinder on the outside and a bowl on the inside, but this bowl is not going to be very effective, right? Because if anything you put in, it's just going to go right, it's going to filter down and fall out the hole in the bottom, okay? All right, so what are we going to do? We are going to do our, just like always, please.
X equals 8 instead of y equals 8.
Thank you. If you were thinking that earlier and you didn't speak up, shame on you. Now we got it? Okay, yeah, so yes, I will make mistakes, maybe a couple a week. If you're catching a mistake, please speak up. Please speak up, okay? Are we good now? Okay, so we're going to do our typical strip here. And to calculate this volume, we look at what does the typical strip do when you rotate it about y equals 70. So what are you going to get when you rotate that typical strip about y equals 70? Well, it's gonna rotate and it's gonna end up being like this up here at 180 degrees. Imagine that. What will that be? So it's kind of like a pancake, but what's different about it? It's a hole. It's a hole in the center. So we call this a washer. A washer. A washer is a pancake with a hole in the center. That's what we're going to get. Okay? Like that. That's our typical element, right? They're gonna, on the left side, they're gonna have a really big hole in the middle. And then as we move to the right, that hole's gonna get smaller and smaller and have greater and greater volume, these typical strips. So the last one has the hole that's, the last one on the right has the hole that's this size right here. First one will be almost, it'll be like all hole, right? It'll be all hole, and then the hole will get smaller until you get to here. Are we good? So how are we going to get the volume? So we need the volume of a typical element here. How are we going to get that? So our geometry, so what is the volume of that thing? Yeah, so it's going to be the big pancake, right? The whole pancake minus the pancake that's missing. So it's going to be volume, say outer, we'll call volume outer minus volume inner. And those are both cylinders again. So it's like we got a pancake that's the whole size of it, and then we have like, we're like cutting out a pancake in the middle. So we got pi r squared h. So pi outer radius squared h minus pi inner radius squared h. So the question is, what's the outer radius? What's the outer radius? The outer radius is the distance from center of rotation out to the outer radius. What is that? So this is our outer radius. And what value or expression is that? It's always 70. Do you see that? All of these, the outer radius for all of the typical washers is 70 because it's the distance from the x-axis up to 70. No matter which one, the one at the far left, the one at the far right, all the ones in the middle have an outer radius of 70. That's easy. That's good. Okay, inner radius. Inner radius is from there to there. So now this is, we've seen these before, things like this in previous problems where we, so can you figure out what is that inner radius? Take 1 minute, see if you can get, how would you write an expression for the inner radius? Go. Go. So here's a hint. It's a change in y. It's a change in y. Okay, so you should have came up with, it's just 70 minus y. The y coordinate on this curve. The y coordinate is just the height from the x-axis. So it's just 70 minus y, the y coordinate of the curve. How many people got it before I did it? Okay, half of you. All right, so that may be so those kinds of expressions are maybe the trickiest for students. You got to really practice that. So it's a change in y. The final y is 70 to get to that inner radius, and then the lower y there is the height of the curve, and that's just the y coordinate. All right, what is our h for these washers? This is our h right here. What is that? Change in x, right? This is change in x. So we got to get that y in terms of x for that. Well, that's just x squared. We've got it. So we're ready to write this down. Outer radius is 70 minus inner radius is 70 minus the y coordinate in terms of x for that curve is just simply x squared. So that's our volume of our washer. Setup work in a box. Questions on how I got that? Big pancake minus smaller pancake, which is the whole. Subtracting out the pancake, that's the whole. Okay, now we're ready to set it up. Let me just write it down. So where's the first one and the last? So the first one is that one that's almost all whole, right? That's at x equals 0. And the last one is this one way over here on the right. It's 8. So we'll just do one dx. We'll just factor out the dx. Questions? Please. Yeah, sure. Yeah, sure. Questions about the setup? Okay, your turn to work on one. Okay, go. See if you can make progress in about 4 minutes. Okay, you're going to use horizontal washers. Horizontal washers, parallel to the x-axis.
Look, we're not just police. We're also here to help if you have questions.
Okay, so we got the washer formula. Maybe the trickiest part is getting R outer and R inner. So R outer is, no, not quite. It's from here to 9. So it's a change in x. See that R outer is a change in x from this curve to 9. So it's going to be 9 minus the x coordinate of this curve. So the so-called x outer, right? So it's the x coordinate of this curve. That's going to be R outer. And then R inner is also 9 minus, but the x coordinate of the line. Since we have delta y, we got to get x outer and x inner in terms of y. So it's going to be 9 minus, what is x outer? Well, that's the x coordinate on the curve out here, which is our y squared. X inner is the x coordinate of the line. Which is 6 minus y. We want minus that x coordinate, so it's going to be minus in parentheses 6 minus y. Because 6 minus y is the x coordinate, and you're subtracting the x coordinate, so you've got to put parentheses there. That negative will distribute. So that's the volume of our washer. And so our integral is going to be from what to what? The first one is at the bottom. It is at 0. The last one is right here at this intersection point. What's the y coordinate of that intersection point? 2? Is that the point 42? Yep. That's the point 42. So that last one is up here at 2. Okay? And then we're going to have pi times 9 minus y squared minus pi times 9, what is this? 3 plus y? If we simplify that, you get 3 plus y in there. Okay, so solving that antiderivative is just a matter of multiplying everything out and getting a big polynomial. It's just it's long but easy, right? Long but easy. You have to multiply out all that stuff, do a long polynomial, and solve that.